You will find this solid pipe example in the examples manual on pages 199 to 207. Page 207 contains the full command file that you can copy and paste into the text box or recreate the commands listed using the dialog boxes. This is a good exercise for you to learn and practice TrueGrid. We assume, as we do with all of the intermediate examples, that you have already completed watching the introductory video series and that you have mastered the fundamentals of TrueGrid by practicing the examples in your training guide. In this example, the techniques of building a butterfly mesh for a cylinder are extended to a curved pipe. In a previous example, the full solid cylinder on page 189 of the examples manual, the block part was initialized so that the outer blocks were collapsed onto the inner block. This made it trivial to project the outer faces to the cylinder. This works well because of the symmetry of the cylinder. For a more general problem, where the center line of the butterfly is a curve instead of a line, this method does not work. Projection is still the best method for building the butterfly structure in this more general case. The edges, and consequently the faces, of the block mesh will be initialized using 3D curves. If the edges are properly shaped with these 3D curves, then the faces of the mesh will initially be close enough to the surface of projection so that the projection produces a good mesh. The projection method can only deal with a modest amount of curvature between block partitions. When 3D curves which approximate the surface projection are used to initialize the mesh before projection, then this limitation in curvature no longer applies. This will be evident in this example. The first step in the construction is to create the geometry. A 3D spline curve forms the center line of the pipe. The pipe surface, with varying radius, is formed along this curve. 2 additional surfaces are used to form the ends of the pipe. 4 curves along the pipe surface will be used to initialize the outer edges of the mesh. In this example, they're extracted from the pipe surface. These are known as contour curves. If more than one surface is needed to form the outer surfaces, this method of extracting 4 contour curves may not work, since a simple contour like these can only be extracted from one surface. Spline curves can be used, but they may only have the control points in common with the surfaces. This is acceptable since it is not essential that all 4 curves be precisely on the outer surfaces. The projection will pull any stray edge nodes which were initialized to a curve onto the surface of projection. There are 2 critical features needed in the construction of these 4 curves. First, they should be smooth. This is why the spline curve works so well. Second, the 4 curves need to be spaced about 90 degrees apart from each other along the circumference of the cross-section of the pipe. It is also important that they do not twist around the pipe as they traverse the length of the pipe. This produces a good interior mesh, but the interior block going down the middle will be formed with straight line edges. Additional curves are needed for the interior edges to form a good interior mesh. The interior curves are formed by interpolating the 4 outer curves. Then the interior edges are attached to those interior curves. A portion of the spline curve is visible inside the pipe surface built around that curve. To create the 4 exterior contour curves, let's first label the surface points on the pipe surface and examine the point syntax and the number of contour lines. We want the 4 curves 90 degrees away from one another. The 4 exterior curves are formed using the curd command and the begin with surface contour option. If you do not know how to use the curd command to make contour curves, watch our introductory video named 3D Curves, as this is an important foundation for this example. There are 108 contour lines on this pipe surface. We want to start the first contour curve at 13. To evenly space the subsequent 3 exterior curves around the circumference of the pipe, we will want to space them in intervals of 27 contour lines away from one another. I'm going to speed up now and add the remaining exterior curves. Now we are going to use the 4 exterior curves to extrapolate the 4 interior curves. We are going to extrapolate using the exterior curves that are 180 degrees from one another. And we are going to use 0.3 and 0.7 as our interpolation parameters for the curves. I'm going to speed up now and add the remaining interior curves. Now we are going to add our block mesh. As I'm sure you've already mastered the block mesh command at this point, I'm simply going to copy it from the examples manual directly into the text box. The initial part consists of 9 blocks. The x direction is associated with the axial curve of the pipe surface. There are 2 reasons to get the block part close to the geometry in this case. First, if it is not close, you can get confused as you are attaching and projecting portions of the mesh. If you are not concerned about this, then you should attach edges first and then project the faces. The second reason for initializing in a reasonable way is that the cure command determines which ends of the mesh should be attached to which ends of the curve. If the initial position is bad, it will make the wrong choice. The next step is to remove the 4 corner blocks that are not needed. You can select each block individually and then use delete, or use the computational window to select these blocks. Click and drag for each of the 4 intervals in the J and K index bars. Then click the delete button. Alternatively, use the DE or the DEI commands found in the mesh menu. The remaining 4 outer faces can be projected to the pipe surface. This can be done in one step by selecting the faces as shown in the computational window. Select the surface and click on the project button. Alternatively, use the SF or the SFI commands found in the mesh menu. The corners that were deleted are still evident in the picture. The next step is to use the 3D curves to close the gaps. One edge is selected in the computational window. Then select the appropriate 3D curve. If you click on the Attach button, then the edge will be attached to the curve, but the end nodes will not necessarily be placed on the end of the 3D curve. This is not critical, since the end faces will also be projected to the end planes. This can also be done using the curves command found in the mesh menu. Similar steps are taken to attach the opposite edge to the same 3D curve. Select the edge in the computational window, select the 3D curve, and attach. Each pair of edges must be attached to the appropriate exterior 3D curve for each corner block that was deleted. The interior block is still linear. This is fixed by attaching the 4 interior edges to the appropriate 3D curves. One edge is selected, the appropriate curve is selected, and the edge is attached. Again, the easiest method for attachment in this case is the cur command. All 4 edges are attached in this manner. The result of all 4 attachments is shown here. If the part has been poorly initialized, and if the attach button was used instead of the cur command, then it is possible that the nodes of the 2 edges that form a seam will not be aligned. Simply move the end node of one edge to the same position as the end node of the other edge to fix the poor initialization. In this case, it is not necessary to move the nodes to match the location of the corresponding node, because in this case, we're going to project both end faces to the bounding planes. Select the end faces in the computational window, select the plane, and project. And now you have a high-quality mesh. The last step is to increase the mesh density to improve the curvature at the pipe boundary. Use the MSEQ command to add elements to each block.